Hello everyone, welcome to my channel. In this video, I will explain about Ensemble Learning. So one of the most important question, this notes is enough to write the exam. Ensemble Learning is a machine learning technique where multiple models are combined to build a strong and more accurate model. So in general, what is going to be happened in the Ensemble Learning? We are going to combine multiple models. Okay, so in order to build a strong and more accurate model, so we are going to combine 3 or 4 or more models. By the way, we are going to build strong and more accurate model. So please remember, all of you, it is a supervised learning technique. So what is the meaning of supervised learning technique? It is going to use the labels. Okay, now let us see the types of ensemble learning. So first one is called as voting, so which is also called as averaging. Second one is the bootstrap, which is also called as bagging. Third one is the random forest, and fourth one is the boosting. Last one is the stacked generalization. Okay, so we'll see one by one now. So what is the meaning of voting? So what is the meaning of voting? Remember, all of you, voting is also called as averaging. Okay, so voting is an ensemble machine learning algorithm that involves making a prediction that is the average. Okay, so we can say average nothing but regression or the sum classification of multiple learning models. So what is going to be happened in the voting? We are going to predict the output based on, okay, average or sum. So in other words, average we can say regression, and sum we can also say this is called as a classification. So in the voting, this regression and classification will play a role. You observe the example regarding voting. So there is a data point is there on the screen. So we have the data is there. So the data point. So we have given some data here. So here we have given some data. So what is going to be happened in the technique called as voting? So we are going to use different models. Let us say in the first case I used KNN, K nearest neighbor. In the second case, I used decision tree, and I used something log regression techniques. So what is going to be happen after completion of using these models? KNN gives the prediction output as 1, decision tree predicted output as 0, log recovery will predict the, let us say, output as 1. And then this voting classifier will play a major role in the voting. You observe here what is going to be happen. The voting classifier will take the output all here all predictions. It will take 1, 0, 1, but it will select which is the maximum. Here the prediction could be 1 because the values are 1, 0, 1. So number of zeros are 0, number of zeros are 1, and number of ones are 2. Hence, the answer could be, the prediction could be 1. So this is called as what we say voting. Now let us go for second one. This is called as bootstrap aggregation. So it is also called as bagging. So bootstrap aggregation is also called as bagging. It is a machine learning ensemble meta algorithm designed to improve the stability of accuracy of machine learning algorithms like classification and regression. It decreases the variance, okay, and helps to avoid the overfitting. So it is also a machine learning algorithm where it is used to improve the stability and accuracy of machine learning algorithms. So it is usually applied on decision trees. Very important keyword. Please note down, all of you. When you observe bootstrap, the keyword is decision tree. Okay, so we are using in especially decision trees. Bagging is special case of the model averaging approach. So this is the special model of averaging. So first we talk about the voting or averaging. So this bagging or else we can also call it as bootstrap. It is a form of, it is derived from, it is a model of averaging approach. Okay, now you observe on the screen. So actually this is the diagram which is related to second approach, is also called as a bootstrap aggregation. Now you see what is going to be happened in this diagram. You observe, first we have given some input data here. So we have given some input data, and the data could be, you observe here, this is the data we have given to the model, to the system. So what is going to be happened in general, first this data could be trained, this data could be trained. Okay, so whatever the data we have given, that could be in this divided, and those data could be trained using some models. Okay, so there is a model. So first what will be happened, we have given some data, so the data could be divided and we train. So after completion of that one, the data could be taken some model and it will predict the output. You observe, model 1 predict the output as 1, model 2 predict the output as 2, and model and so on. So what is going to be happen? Finally, bagging classifier will decide the prediction. So this is called as what we say bagging concept. So this is the main important diagram for bagging concept. Okay, so let us go for third one. Third one is called as random forest. Okay, so what is the meaning of random forest algorithm? So random forest is a ensemble method where multiple decision trees are constructed, then they are merged to get the more accurate prediction. So remember, in the random forest we are using multiple decision trees. Okay, so are constructed, then they are merged. So first we will construct different decision trees, we are going to merge. So by the way, we are going to predict the output. You observe on the screen. So this is the example related to concept called as random forest. Now you see, so actually this is a diagram related to random forest. So we have given some input data on the screen. Okay, so after completion of giving the data could be divided as some decision trees. So this could be one decision tree, this could be one decision tree, this could be another decision tree. After completion of deriving a tree, it is going to predict some output, it is going to predict some output, it is going to predict some output. So after completion of prediction, what is going to be happen? It is going to do all average predictions. So this is important point. So in the previous we have taken maximum, but here it is used to choose something called as a average of all predictions. Okay, so this finally random forest prediction will give the some output based on the input given as a input data. So this is called as what we say random forest. Okay, so this diagram very important. Please note down all of you. So this is the most important diagram for random forest. Okay, so now let us go for fourth one. This is called as boosting. So what is the meaning of boosting? Boosting is an ensemble model technique that attempts to build a strong classifier from the number of weak classifiers. Very important. So what is the meaning of boosting? We are going to build a strong classifier with weak classifiers. It is done by building a model by using weak models in series. First, a model is built from the training data. Then second model is built, tries to correct the errors present in the first model. Okay, so what is going to be happen? We are going to build a strong classifier based on weak classifier. Okay, so this is called as what we say boosting. So the procedure is continued and models are added until either the complete training data, the set is predicted correctly, or maximum number model is added. So in this, what is going to be happened? We are going to take a weak classifier. So we are going to build a strong classifier. You observe here, this diagram belongs to boosting. So this is called as input data. Okay, after completion of input data, we are going to use some classifier. Okay, so this classifier will generate some data. Again, after completion of this classifier, we are going to get this data, and we are going to add some weights to here. Okay, so we are going to add some weights. So again, we'll have some classifier. So we'll do, so this procedure is continuous until we get the correct output. So what is going to be happen in short here? We are going to do, this procedure is continued until the models are added, until either the complete training data is predicted correctly or maximum number of model is added. So whatever the input data we have given, that could be have will be given into some classifier. So this is called as a classifier. In this this boosting, what is going to be happen? It will predict some data. Okay, so the data could be 0 0. This some symbols are there. So after completion of this one, what is going to be happen? We have given data to weighted. So this is called as what we say boosting. Okay, so last one is what we have, stacked generalization. So what is the meaning of this stacked generalization? So stacked generalization nothing but blending. So we can say this concept is called as a blending. Okay, so stacking, blending and stacked generalization all are same thing. So remember, stacked generalization is also called as blending. Stacking, blending, stacked generalization, all terms are same. It is a kind of ensemble learning. In this, multiple base models are combined using meta model to improve the prediction. Okay, so we are going to combine all models. So you observe on the screen, this example belongs to blending. So you see, we have given some input data. So what is going to be happen? The data could be trained with different models. So after completion of this one, we are going to use some algorithms will predict some data. Let us say first data could be used something called as decision tree. So first training data could be used decision tree. The predicted output is 1. So let us say second training data regression, and the predicted output is 2. So this is similarly we are going to n. So we are going to use lasso. So the prediction is 1. So what is going to be happened? So after completion of this all predictions, this stacked data set could be taken all these, and this second level meta model will give the final value to the prediction. Okay, so this is called as what we say stacked generalization. Now this is also one of the most important point. What is the difference between bagging and boosting? So bagging and boosting both are ensemble learning techniques used to improve. Okay, so used to improve the model performance by combining multiple models. So bagging reduces variance by training the models or independence. Boosting reduces by bias. Okay, so bagging reduces variance, boosting reduces bias. So you see, this is a diagram for bagging. So already we discussed in the above. So this is a diagram for boosting. Okay, now you see, this is the main differences between boosting and bagging. So what is the meaning of a training style? So what is how the training style could be in bagging? It trains independent models. Okay, so bagging train style is it trains independent models, but in boosting it trains the sequential models. You observe second one, the goal of bagging is reduce variance, the goal of boost is reduce the bias. So what is handling error? Handling error, all data treated as equally in bagging. So in handling errors boosting, misclassified data gets more focus. So fourth one is the overfitting. So bagging reduces overfitting. Okay, but boosts cannot reduce, but it is having high risk. So next one is the parallel training. It supports PT, it supports parallel training, but it does not support. And model weight, equal weight to all models. Okay, when it comes to bagging, equal weights to all models, but when it comes to boosting, it does not have different weights to models. So we are using in this equal weights bagging, but boosting different weights. So speed is very fast and this is very slow. So this is all about the ensemble learning techniques, one of the most important question in the exam. Thank you for watching this video. Please subscribe my channel. Thank you one and all.